Hello everyone, welcome back to NCET Prarambh MCQ series. So this is day 2. In today's video, we are going to discuss MCQs based upon the subject domain chemistry. So I am Vinayak, your chemistry faculty, and we are going to discuss MCQs from the chapter haloalkenes and haloarenes. Which of the following is most stable? 1 butene, 1 pentene, 2 butene, 2 pentene. See here, most stable. So all the options, if you observe, all are present in alkene form. So we know that stability of alkene is directly proportional to number of alkyl groups, or we also know that it is directly proportional to hyperconjugation. Now, if you see first option 1, 2, 3, 4. So 1 butene. So 1, 2, 3, 4. So this is 1 butene. Second one is 1 pentene. Third one is 2 butene. That means double bond is present for second carbon. And fourth one is 2 pentene. 1, 2, 3, 4, 5. So you remember one point, if double bond is present at terminal, in the molecule, then remember it is less stable. The double bond which is present in internal, so that is compared to terminal position, inner position, the double bond which is present, it is more stable. So easily we can eliminate first and second option. Now we also know that stability is directly proportional to number of alkyl groups. So here 1 and here 2. 2 alkyl groups is present for double bond. In fourth option, here also 1 alkyl group. Here compared to the third one, here the C2H5, it is bulkier group. The alkyl group which is present, it is bulkier group. So easily we can find out that fourth option is correct one. More number of substituent groups or more number of alkyl groups, then it is more stable. Okay. Next question. Preparation of alkyl halides in laboratory is least preferred by halide exchange, direct halogenation of alkanes, treatment of alcohols, addition of hydrogen halides to alkenes. So choose the correct answer from the options given below. First one A and B only, second one A and C only, third one A, C, D only, fourth one B only. So according to NCET, if you see any chemicals which we are going to prepare in the lab, it should be controlled and it also gives major product. So first option you see halide exchange. We know that for this halide exchange method we have two types of named reaction. One is Schwarz and another one is Finkelstein reaction. So it gives specific halides. So we can easily prepare in the lab. Second one, direct halogenation of alkanes. While preparing alkanes, direct halogenation of alkanes will get product in the form of mono, di, trihalogen compounds. So all mixture of mono, di and trihalogen compounds. So it is uncontrollable. This method of preparation is uncontrollable. So second option is not preferred. Third one, treatment of alcohol. This we can prepare easily and we are going to control the product. Addition of hydrogen halides to alkenes. So this is also specific reaction we can easily prepare in the lab. So among four, if you observe, only second option is less preferred in the preparation of hydrogen halides in lab. So which option is correct? Option 4, B only is the right answer. Third question, which of the following pairs are correctly matched? So they gave a list of reaction along with the products. Now we have to check the given pairs are correctly matched or not. So we'll write the direct answer, then we'll check which among the following pairs are correct. AgCN, if you see AgCN, it is a covalent compound. So now between carbon and nitrogen, nitrogen is more act as a nucleophile. So it is having characteristics of more nucleophile. So we'll get product as a alkyl isocyanide. So the first pair is correct. Second one, alkyl halide in the presence of potassium cyanide. Potassium cyanide is ionic compound. So now it will release as a K plus and Cn minus. Carbon which is having negative charge, it will act as a more nucleophile than nitrogen. So because of this reason, alkyl cyanide we are going to observe. So second pair is also correct. Now alkyl halide in the presence of KNO2. So KNO2 is also a ionic compound. So now, as we know that compared to nitrogen, oxygen is acting more, it will act as a more nucleophile. So alkyl group, oxygen will be attacking, then nitrogen with double bond O. If you see the option, this is not a correct pair. Now alkyl halide in the presence of AgNO2. So this AgNO2 is covalent compound. Now in covalent compound, nitrogen will be acting as a more nucleophile. So we have to get the product alkyl group which is attaching nitrogen, then double bond nitrate group. So this pair is also not correct. So then which option is correct? Second one, first and second given pairs are correct. Fourth question, phenol is obtained by. So the four reaction they give, we have to check among which of the following molecules will not get phenol as a product. So we'll write the reaction, then we'll understand. We can easily choose the right option. Now first one, if you see, sulfonic acid is present in the presence of NaOH and H+. So completely this group will be replaced by OH. So we are getting here phenol. Third one, if you observe OMgBr, Grignard reagent, upon hydrolysis, we know that we'll get phenol as a product. Now, see here, carboxylic acid substituent or group is present in the presence of NaOH and calcium oxide. So this is decarboxylation. So in decarboxylation, what will happen? Complete COOH group will be removed. So we'll get product here, benzene, not phenol. Remember. Now here in the presence of NaNO2 along with HCl, if you see here, we'll get first as a intermediate product N2H, N2Cl. Upon hydrolysis, will get here phenol as a substituent group. So now which option we are not getting phenol here? Second option. So the fifth question is, the product of the following reaction is. So we have to choose the correct option which we are going to get as a product. So first we'll write the reaction, then we can choose the correct option. See here. So this is carbon 14 or the isotope carbon, which we can track the reaction mechanism. Okay. See here, the allyl group which is present here, it will shift towards ortho position of the benzene. The allyl bond which is attached to the oxygen bond, it will shift towards carbon which is present at ortho position in the benzene. Now, so this mechanism will happen based upon sigma-trophic shift. Sigma-trophic shift. That too, we can call this 3,3 sigma-trophic shift. Now see here, the double bond which is there, it will shift here, this bond will break and this bond will shift, and here formation of new bond will happen. So then we'll get product with oxygen double bond. See, this is new bond formation, here bond breakage will happen. Now we know that ketone group is less stable, so because of that now keto-tautomerism will take place. Keto-tautomerism. So now this ketone group will be converting into aldehyde group. So now we are going to get final product with OH, then we are getting the shifted of allyl group. So this is our final product. Okay. Now the carbon 14, this is present here. So now among 4 options, which option is showing the product here? So this option is not correct. This option is also not correct. But here double bond is not present. So first option is correct. So the first option A only is our right answer. Now the sixth question is, which of the following statements are correct for SN1 reaction mechanism? The rate of reaction depends only on the concentration of alkyl halides. A carbocation intermediate is formed. The reaction proceeds through a single step mechanism. Polar protic solvents favors the reaction. So among these 4, which are the following we have sentences are correct, we have to choose. See the first one, the rate of reaction depends only on the concentration of alkyl halide. So this is correct. Second one, carbocation intermediate is formed. So carbocation formation is also there in SN1 mechanism. The reaction proceeds through a single step. So this is wrong option. See here, SN1 mechanism, it is a 2-step process. So first one, formation of carbocation, and second one, nucleophile attack is there. Nucleophile attack is there. So third option or option C is not correct. Fourth one, polar protic solvents favor the reaction. So this is also correct option. So polar protic solvents, it stabilizes carbocation and leaving group. So only option C is wrong. Now choose the correct answer from the options given below. A is correct, B is correct, D is correct. A, B, D. So the first option is your right answer. So the seventh question is identify the principal organic product of the following. So among four options, which of the one option we are going to get as a product? See, this reaction is example for nucleophilic substitution reaction for aromatic compounds. Now, in the presence of NaSCH3, see here NO2 group is present. So this NO2 group is electron withdrawing group. So this is present at para position. So it will stabilize the complete benzene ring. Now, along with that, fluorine and bromine is also present. Fluorine is present at para position, bromine is present at meta position. Bromine is present at meta position. Now, between these two, fluorine will act as a good leaving group because it is present at meta position and it is highly reactive. Because of that, instead of bromine, fluorine will leave from this group and this complete SCH3 will attack on fluorine position. So we'll get product NO2 and here SCH3 and bromine will remain as it is. So which option is correct now? Option 2 is right answer. Now, eighth question is which of the following statements are correct regarding solubility of haloalkanes in water and organic solvents? So first one, haloalkanes are only sparingly soluble in water due to absence of strong intermolecular attraction with water molecules. So first option is correct because always remember hydrogen bond will not form between water molecules along with haloalkanes. Now second one, dissolution of haloalkanes in water requires energy to overcome the hydrogen bonding between water molecules. So always remember between water molecules to break the hydrogen bond energy is required. So this option is also correct. A large amount of energy is released when haloalkanes interact with water molecules leading to high solubility. This is wrong. Amount of energy is required to break the bond, not released. So third option is not correct. Fourth one, haloalkanes are generally soluble in organic solvents due to comparable intermolecular forces. So this is correct option. So among these four, first option is correct, second option is correct and fourth option is correct. So here second A, B, D only is the right answer. So next question, see here, the chlorine bond or the carbon chlorine bond in chlorobenzene as compared with carbon chlorine bond in methyl chloride is first one longer and weaker, second one shorter and weaker, third one shorter and stronger, fourth one longer and stronger. So now we have to compare the carbon chlorine bond in chlorobenzene and methyl chloride. See here. So this is chlorobenzene. So this is methyl chloride. Now, the carbon which is present here, the carbon which is present here, this carbon and the chlorine atom, between these two, p orbital overlap will happen. Between these two, p orbital overlap will happen. Because of this overlapping, this between carbon and chlorine there is a partial double bond characteristics will be there. Partial double bond characteristic will be there. Now we know that single bond is having more length than double bond than triple bond. Now because of this double bond, here we are going to observe, so partial double bond character we are observing. Now because of this partial double bond character, the bond length is decreased, but bond strength is increased. Bond strength is increased. This is in first case. In second case, carbon which is attached with chlorine, it is single bond. There is no resonance, there is no double bond. So now because of this reason, in second case, bond length is more. Bond length is more, but bond strength is less. Bond strength is less. Now which option is correct? See here, longer and weaker, shorter and weaker, shorter and stronger, longer and stronger. So the correct option is shorter and stronger. Shorter and stronger. Third option is correct. 10th question. In Finkelstein reaction, alkyl chlorides, bromides are converted into alkyl iodides using A in B medium, whereas in Schwarz reaction, alkyl chlorides or bromides converted into alkyl fluorides using C. So choose the correct answers for A, B, C from the below options. So they gave a different products or different solvents along with that. So we have to check among these four which option is right or correct one. So we know that in Finkelstein reaction, alkyl chlorides or bromides will be converted into alkyl iodides in the presence of sodium iodide and acetone. Okay, so here B, acetone, sodium iodide and acetone. Whereas in Schwarz reaction, alkyl chlorides or bromides converted into alkyl fluorides using AgF, silver fluoride. So which option is correct? Option 2 is your right answer. So 11th question, match the haloalkanes with most appropriate mechanistic feature involved in the reaction. So primary alkyl halide. Transition state involves simultaneous bond breaking and bond making. Secondary alkyl halide, competing pathways possible depending on reaction condition. Tertiary alkyl halides, rate determining steps involves heterolytic cleavage of carbon halogen bond. Fourth one, allylic halide, which intermediate form is stabilized by delocalization of electron. See, primary alkyl halide, it is more reactive towards SN2 mechanism. So in SN2 mechanism only we are going to observe bond breaking and bond making simultaneously. So this pair is correct. So for A, 1. Secondary alkyl halide, competing pathways possibly depending on reaction condition. So this secondary alkyl halide, it may go to SN2 mechanism or it may come SN1 mechanism. Based upon the given conditions, it will react. So second option is also correct. Third one, tertiary alkyl halide. So tertiary alkyl halide, it is more reactive towards SN1 mechanism. So rate determining step involves heterolytic cleavage of carbon halogen bond. So this one is also correct. So A1, B2, then C3, then obviously D will be 4. So allylic halide intermediate formed is stabilized by delocalization of electron. So stabilization of carbocation will take place in the presence of allylic halide. So first option will be your correct answer. Now see next one. 12th, the synthesis of alkyl fluorides is best accomplished by. So just now we studied, that is Schwarz reaction. 13th, benzene disonium chloride reacts with hypophosphorus acid to produce. So we know that benzene disonium chloride reacts with hypophosphoric acid to produce here benzene. See here. N2Cl in the presence of hypophosphorus acid H3PO2. So this complete molecule will be replaced by hydrogen. So we'll get product here benzene plus N2 plus HCl. Okay. So benzene is the correct option. 14th question. So identify the product. So the reaction is given, so we have to identify the product. See here, first one, in the presence of Cl2 and Fe. So what we'll get here? So in first step, SO3H will remain as it is, bromine will remain as it is, but at meta position, chlorine will be attacking. So now the second step, in the presence of water and acid, they are going to heat. So desulfonation will take place, removal of SO3H, and finally we'll get product, but bromine and chlorine remain as it is. So the third option is correct. 15th question, which of the following reaction not give simple product or same product? So 15th question, which of the following reaction not give same product? So we have to identify among these 4 different reactions where we are not getting as a same product. See here. Now in first case, in the presence of H plus, we know that one bond will break, here carbocation formation will happen, here negative charge for this H plus will attack. We know that carbocation stability, so tertiary carbocation is more stable than secondary than primary. So because of that, it will shift to tertiary carbon. Now this bond will break and new bond formation will happen. So 5-membered ring, now it will be converting into 6-membered ring. Ring expansion is taking place. Now in second reaction, AlCl3, this is Friedel-Crafts reaction. Now chlorine will be removing and we are getting here CH3 with plus charge. Okay. Now in third one, OH group is there in the presence of H plus, then OH and H plus it will be removing as water molecule, and here also we are getting as a intermediate product which CH3 plus charge. Okay, this is 6-membered ring, not a benzene, don't get confused. In fourth option, if you observe, already this OH group, if it is removing, carbon is forming at tertiary carbocation. So plus charge is forming a tertiary carbocation. So here we are getting different product. Here we are getting different product. So now which option is correct here? Fourth option, option D only. So all remaining three we are getting as a same intermediate product. After that it is reacting with benzene, we'll get final answer. Okay. So option 4 is the right answer. 16th one, Freon 12 can be prepared by. So this is fluoride compound F12. So we know that fluorine compounds or fluorine halides will be prepared by using Schwarz reaction. 17th question. Which of the following compounds will react with fastest rate with aqueous NaOH? Now we know that any compound or any benzene compound, if it is attaching with chlorine, if it is undergoing in the presence of NaOH or aqueous NaOH, this type of reaction will come under nucleophilic substitution reaction for aromatic compounds. Usually this reaction is very slow, but if this is attached with electron withdrawing group, okay, electron withdrawing groups at ortho and para position, then reaction will proceed faster. So among four options, which option is having electron withdrawing group? C and D. Now 2 NO2 presents, NO2 groups are present at ortho position, 1 NO2 group at para position. So in fourth option, we have 2 NO2 groups is present at meta position, 1 NO2 group present at para position. So now which option is correct one? Option C. That means C only. Fourth option is correct answer. So 18th question. Find the total number of halogen atoms present in the major end product for the given reaction. So they gave 1, 2, 3, 4, 5, 6 reagents. Then we have to find major end product. In that major end product, how many number of halogens are present? So we'll solve this equation, then we'll see what is how many number of halogens present at major end product. Now, so both side NO2 group is present. In the presence of NH2SH. So always remember this O2 will be replaced by hydrogen, then we'll get product here NH2 and NO2. Now in the presence of bromine water, that excess bromine water, so we know that, so 2 bromine will add at ortho position. So addition of bromide ion NH2, so here Br, so one more Br, here NO2 will be there. Now NaNO2 and HCl. So next it is reacting with NaNO2 with HCl. Now this hydrogen will be replaced by nitrogen and chlorine. So benzene diazonium salt formation will happen. N2 plus Cl minus. Now this is reacting with CuBr in the presence of HBr. Now in the presence of CuBr and HBr, now bromine addition will take place. So here bromine will be present as it is. So we'll get product. Bromine is attached at ortho position, para position. So instead of this N2Cl minus, bromine is replaced. Now this molecule they are treating with Sn and HCl. So they are treating with Sn and HCl, tin with hydrochloric acid. Now this NO2 group is converting into NH2 group. So Br, bromine will be there as it is, and here this will convert into NH2 group. So after this, in the presence of again bromine water, addition of bromide ions will take place. So Br, 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 Br in remaining position, and finally it is NH2. Now how many halogens present in the major product? 1, 2, 3, 4, 5. So 5 halogens are present, halogen atoms. So which option is correct? Second option is correct answer. Now 19th question. In the following reaction sequence, the final product C is. So they gave a reaction, we have to find the final product C. So first we have here C6H5 NH2 in the presence of NaNO2 along with HCl. So here BDS formation will take place. So N2 plus Cl minus. Now in the presence of CuCN and KCN, addition of cyanide will take place. So Cn. For this they are adding H plus and H2O. So finally this Cn will be converting into carboxylic acid. Hydrolysis. COOH. So this is our final product. So this is A, B, C. So C is our final product. C6H5COOH. So fourth option B only is the correct answer. 20th question. Which of the following products will be formed in the given reaction? So we have to find the products. See, pH, so pH in the presence of oxygen and heat. So now addition of oxygen will take place. pH COOH. So pH will be remain as it is. So this is A. Now for this they are going to treat with H3O plus and along with that heat. Now, so what will happen here? This pH will shift here and this oxygen bond will shift. So pH will shift and this oxygen bond will shift. And finally we'll get two different products. One is pH with OH and another one pH to C double bond O. So after moving this pH here, then C double bond O formation will happen. So we are getting two different products. These two. So where we are observing this in option? So pH OH is in second option, pH to C double bond O in third option. So both B and C. Sorry, this is both second and third. So option 4 is the right answer. So make a correction, it is both second and third option. Okay. Now next question. 21st. When two halogens are attached to same carbon atom, it is known as gem dihalide. So vicinal dihalide means for adjacent carbon atom it will attach. 22nd question. Gamma hexane is chloral, BHC, DDT and HCB. So second option is correct. BHC, benzene hexachloride. So it will be like this. BHC. Okay, second option is correct. 23rd question. Among the following insecticide is BHC, phosphine, chloral and aspirin. So BHC is the correct option. Now, phosphine is a poisonous gas. Chloral, it will act as a to avoid DDT, and aspirin will act as a painkiller. So option A is correct answer. Now 24th question. So we have to find the major final product for the given reaction. So first one, in the presence of Br2 and H nu. So we know that addition of bromine will takes place. So bromine will takes place. Now this X will react with alcoholic KOH. So elimination reaction will takes place. Now what will happen? The hydrogen which is present here, the hydrogen which is present here along with bromine, it will get eliminated. So here we are observing double bond formation along with methyl group. Now for this Y along with HBr and peroxide, so we know that anti-Markovnikov rule will takes place. Then we are getting here addition of bromine, addition of hydrogen. So which is the correct option now? Third option is right answer. So 25th question, rectified spirit is a mixture of 95% ethyl alcohol plus 5% water, 94% ethyl alcohol plus 4.53% water, 94.4% ethyl alcohol plus 5.43% water, 95.87% ethyl alcohol plus 4.13% water. So the correct option is option 4, 95.87% ethyl alcohol plus 4.13% water. So 26th question, which of the following is optically inactive? So in the given molecules, we have to identify optically inactive. So if you see, first and second one are optically active, and third one is meso compound. So meso compound, so it is optically inactive. So the correct option is option C. So option 1 and 2 are both optically active. Okay. So 27th question, chloroform and concentrated HNO3 reacts to produce. So chloroform CHCl3 in the presence of concentrated HNO3. So it will produce here CCl3NO2. So option 3 is correct answer. 28th question. So match the following. So we have to identify the compound and uses. So iodoform, earlier used as antiseptic due to liberation of free iodine. So it is correct. Carbon tetrachloride used as a solvent and fire extinguisher causes liver toxicity. Correct. Freons, CFCs, manufactured by Schwarz reaction responsible for ozone depletion. Correct. DDT shows bioaccumulation due to fat solubility and insect resistance. So all 4 are correct. So option 4 is the right answer. So today we solved 28 questions from haloalkanes and haloarenes. So again, in the next classes, we are going to discuss many more questions. So stay tuned and follow our YouTube channel Tej Academy. Thank you.